This is MCT4C day 16. The lesson is 2.6, last textbook lesson for the second chapter on trig functions. 2.6, solving problems involving sinusoidal functions. The goal is to identify key features of a given sinusoidal function, and this is a bit of a setup for what we're doing later. Identify the value of b in each case and calculate the period. Remember, whatever value was given in the function, in this case 3, that the period was just 360 divided by that, right? So this first one's 120. And then, of course, when we graphed it, this graph would repeat every 120 degrees along the x-axis. So here the b value is 0.5, so I've got 360 divided by that, and I get 720. Over here, 4.8, where the 4.8 come from, who knows? How would we graph this? Who knows? Doesn't matter. But whatever's in the equation, I divide that into 360, and this value is going to be the period. That ends up being 75. And of course, the big thing is, today, when we're doing sort of real life trig functions, we're going to want to have periods that aren't in degrees. We're going to want periods that are in days or seconds or hours or something like that. So we're going to be given the period. Well, we want to be able to write a sine function, so that means we have to find this value of b. We got to find b that gives us a period of 180, and we've seen these enough that we know what the answer is. But how do we do it? Well, remember, 360 divided by b is the period, right? But if that's equal to 180, we've seen a few of these already, we can figure out, cross multiply and divide what b is, right? Divide by 180, b is 2. Okay, so that means the sine function with a period of 180 is y equals sine 2x, and probably you could do that without all that work. You knew this one. But what about this one? Well, this one we saw actually earlier in the 3-minute review already. Sine bx, so let's find the value of b, and again it's 360 divided by b, whatever that is the period, 720, and then we can cross multiply and divide to find out what b is, and b is a half here, isn't it? And so I can substitute that one in there, a half. But what happens when it's, oops, not a half, oops. Oh, you know, that's okay. When it's a value like 365. So for instance, we'll find applications that, well, they repeat every 365 days, like temperature, right? It's the temperature is, cold in the winter. If this is winter or January, cold in the winter, then it goes up by June, and then it's cold again, right? And then this period is from day 0 to day 365. These aren't degrees along here. This is days. So if we wanted to model something like temperature, how would we go about doing that? Well, let's start out the same. It's actually the same calculation, isn't it? Whatever my period is 360 divided by whatever goes in the equation. If I want that to be 365 now, cross multiply and divide. Divide by 365. And that value right there, I could write it as a decimal, I suppose, is the b value, right? So it's y equals sine of 360 over 365 x, and that is the b value right there. I could use a decimal, I suppose, but I'm not gonna. This is what we're wanting to do today. So we see the note, expectations, we've been trying to do this the whole chapter, although we're really able to do it not only we haven't been able to actually model much real world situations until today. We're going to use our skills from this unit to investigate models for periodic, i.e. repeating phenomena in real world applications. So we've been called them sinusoidal functions. We can also call them periodic because they repeat. So one thing that repeats is the sunset time, right? The same time every year, the sun goes down at the same time of day. And notice there's some decimals in here, but we shouldn't be too scared about that. It's asking, or says, where S is the sunset time in hours since midnight. So these aren't actually times. Like we can have a time of 1.75, but that's the hours since midnight. And T is the number of months since January. So if we were in January, that would be month 0. Month 1 would be February, and so on. All right. Okay. Well, what's the maximum sunset time? What's the maximum value that this function gets to? Well, how do we think of that? I'm going to draw a little sketch over here just because that's going to help us. Our axis is there, and we get up to a maximum, get down to a minimum. I don't know where these values are going to fit, but what is it? The axis is this n number, right? So the axis is, this is 18.4 here. And then how far up does it go from the axis? Well, the amplitude is 1.75. So the amplitude, I'm not going to write that, I'm going to write that, amplitude 1.75, axis, or whatever, 18.4. And so that means the amplitude, the maximum then, this value is 18.4 plus 1.75. That's just over 20. And this is in hours. We'll show you how to convert that to an actual time in a minute or two, but let's do the minimum first. The minimum would be 18.4. Subtract that 1.75. That's around 16.65. That's this value, 16.665. Now these aren't times, right? These are the number of hours from midnight. So if an hour is 20 hours, well, what time is that? That's kind of like the military clock. That's 8 p.m., isn't it? But the 0.15 hours, we don't tell time that way, right? How would I get how many minutes that is? Well, there are 60 minutes in an hour, so I could just take that decimal times 60, and I get 9 minutes. So that time there is 8 o'clock plus 9 minutes. That's 8:09. See if you can figure out what that one is. I did the little conversion and I got it to be 4:39. So that means in Parry Sound, the earliest the sun sets is 4:39, and the latest the sun sets is 8:09, and those are the actual values that we can get from the function. What's the period? Well, I can see that the b value is 30. Right? B value is 30, but then the period, remember, is just 360 divided by that value. 12. Now, does that make sense? What does it represent? Well, every 12 months, the sunset times repeat, right? What does it represent? The sunset times repeat every 12 months. Well, that makes total sense, doesn't it? Absolutely. What's the last question? When do the maximum and minimum sunset times occur? Well, we could just think about it because, you know, we've been alive and we know when the sun sets late and then when the sun sets early. But let's think about it as far as this function is concerned. We've got most of the stuff for the graph on this little sketch here, right? I'm going to get this out of the way here just because it's confusing me. The cosine function, remember, starts at its maximum. The shift, the phase shift, is 5.7 months. 5.7 months. And remember, the cosine starts at its maximum. So the maximum is at this month 5.7. So maximum at the month 5.7. And I know that's not much of a calendar date, but we'll think about what that means as well. And then I can start thinking about this. If the period is 12 months, that means in 12 months' time there's going to be another maximum. 12 months' time is over here. That's 12 months' time, 17.7 months from January, because t is the number of months since January. Well, halfway between is going to be the minimum. Well, when's that? Well, if this is 12 months from here, the period is 12 months, halfway between is every 6 months. So this is 11.7. The minimum is going to occur at month 11.7. Minimum month at 11.7. Now, when actually is that? Well, if we have a little think about this, it'll make sense. Remember, a little rough work over here. 0 was month January, right? So 1 is February, 2 is March, 3 is April, 4 was May, and then 5 is June, right? So this is in the 5th month from there. So this is June, and then 0.7 months. Wow, 0.7 months. How many days is that? I'd like a date. Well, just like we multiplied by 60 to get the number of minutes over here, well, how many days are in a month? I'm going to say around, I could probably be a little more accurate, but I'd say about 30, right? 30 or 31, depending on the month. 0.7, that's 21st. That's around June 21st, which of course we know around June 21st is the first day of summer. And if we think of it that way, this should be December 21st, and if you go through this process on your own, you will get that. One more example here. Let me just check time. I'm going to stop there. We'll pick it up in video 2.